Okay, so I recently bought myself a function generator to use in audio circuitry and maybe a low frequency radio. It can go from 10 Hz up to 10 megahertz, and it can do PWM, sine wave, triangle wave, saw wave, square wave, and that's it. It was quite cheap and it looks sort of like a kit, but yeah, hopefully it works. On the back there's a fuse, a switch, and a normal computer power socket. Okay, so on the inside it looks like this function generator has a pretty basic construction. Just the input comes from here, from a plug, then it goes directly into a transformer, which has a center tap which is probably used for ground, and then a positive and a negative tap. That goes directly into the PCB where it gets rectified. Interestingly enough, it only has one rectifier, and then that power goes to the two capacitors here. After the power gets rectified, it probably goes into these regulators to get the appropriate voltages needed for this circuitry. On another note, you will notice how much space is wasted from here to here. I think this box was just a standard box which someone used to make their own design. So this is interesting. The BNCs are connected to a small piece of coax that connects to just normal 2 pins. No special connectors, just basic pins that were broken off, or if I broke it. And it just connects like that, nothing special. When I took the board out, I noticed a chip with a heatsink attached to it. This specific chip and heatsink, if the camera will focus, was lying on the bottom of the case, so I think this is maybe the reason why the thing doesn't work. Interestingly, I've never actually seen a DIP8 chip like this with a heatsink. Okay, so this is the power section of, like I showed before. Interestingly enough, it only has one rectifier. I think the common or ground is separated and the positive and negative terminals are connected to the rectifier and then rectified, and then connected across these large capacitors. This is a 7915 negative 15 volt regulator, and on the back it's a 7815 positive 15 volt regulator, and on this side is a 7905 5 volt regulator, negative 5 volt, and on the back its complement 7805 positive voltage regulator. Okay, now that I've disconnected most of everything, I can see now that the frequency adjust potentiometer is a 10-turn potentiometer, and unfortunately it doesn't have a connector to the PCB. The wires are directly soldered, as are the wires for the power LED. Okay, so this is the front. This is where that weird chip that has a heatsink goes. It looks like it has 3 op-amp chips. And I did a quick search on Google, and this appears to be the main chip that generates all the waveforms. This chip from Maxim Integrated apparently is able to generate triangles, sawtooth, sine, square, and pulse waveforms according to its data sheet. The PWM function must be generated somehow with something else, but this is the main chip that does the rest. It appears that this chip is an analog chip, and that this display screen just measures the frequency from this chip and then displays it on the LCD. Okay, so now I'm just going to check that everything has power. Okay, the chip has 5 volts. The LCD screen has a dot, which is a good sign. Okay, so I'm probing the third pin of that missing chip, or pin 3, and I'm able to get all the different types of sine waves, all the different types of waves: sine wave, triangle wave, sawtooth wave, square wave, and a PWM wave. Okay, it appears that the level of the wave is limited by the third part before it enters the final stage op amp. Okay, so it appears the main frequency, or the highest frequency that it can go is 10 megahertz, which is great. Okay, so this Max 038 CPP chip, the main wave chip, is actually quite hot to the touch. I don't know if I should be concerned about that. The rest of the op amps are quite cool, and the other chip is heating up. Okay, so this is now the chip with the heatsink on it. I can see that this is the top notch, so that must mean this is pin 1, and I can see on the PCB here that it has a top notch here, so I take it, I really hope the person who designed it matched these two, otherwise this chip is going to get blown. Okay, it's now connected. Okay, and on the oscilloscope, the final output, it does appear to have a good final output, and it has a maximum peak-to-peak voltage of 19 volts. And I think that's quite impressive for a function generator. Okay, so the only downside is that this LCD display module doesn't work. So that's the next thing to try and fix. Okay, so the person who made this thing was nice enough to include this LCD module. It's completely isolated on its own. It has a small intercell microprocessor, I think, and it's one complete unit. It's actually quite nice, except for the fact that it doesn't work. Most of the chips here are just plain 74HC series chips, just for some basic logic conversion stuff. Here are the chips. Okay, so I decided to pin out all the pins of the connector of the LCD module, and I found that most of the pins are just ground, and then one for VCC, and then 4 are connected to this rotary switch, and then the third pin is unknown. So I take it the third pin is the signal pin, and I connected it directly to a separate power supply, a 5-volt power supply, and I connected the third pin at the top to the probe compensation output of the oscilloscope. And to my surprise, it actually works, and it's actually quite accurate. The oscilloscope has a 5 volt 1 kHz output. So after doing a bit of research, I found that this large intercell chip is a dedicated frequency counter chip. You will have to watch a video in HD to read the part numbers, and this chip does everything. It counts the frequency and it runs the LCD. And it looks like the thing is actually working, which means that the problem must be on the main board. There. Okay, so with the LCD module connected, I've noticed that it draws almost no current. It draws less than 10 milliamps of current at 5 volts, which is quite good, which means it's less than a normal LED. Okay, since the frequency counter module works and the output works, I decided to probe the sync pin of the Max 038 directly and see what it measures. And on the scope, the purple is on channel 3, which is directly from a chip, and the yellow, which it is triggering from, is directly from the output. As you can see, it has peak-to-peak voltage of 500 millivolts. It started at 1 volt and it will eventually just go down to 0. I think the pin on the chip may be damaged. As you can see, the wave is slowly deteriorating. Okay, so just to be clear, I physically removed the pin from its socket so I can probe it directly, so that no other component may drag it down or something. Okay, so I think I finally got a solution to the problem. I physically disconnected the sync pin from the socket, as you saw, and I physically connected the output of the function generator chip to the sync output, and then that output goes directly into a 74HC04 inverter chip that then goes to the sync output on the front panel, and then another output goes to the LCD module that counts the frequency. And this appears to have solved my problem. Okay, now with everything connected up and powered up, you'll be able to see what happened. I physically removed this pin, the sync pin, from the socket and then connected it directly to this inverter chip. As a matter of course, I just replaced the inverter chip with a new one, just to be sure that that wasn't a problem. And it appears to work. It's now set to 11 kilohertz, and it can go up to 10 megahertz if it's in a square wave, if it outputs a square wave. Okay, so on the bottom is the main output of the function generator, and at the top is the output going directly to the LCD frequency counter module. Currently it's at 11 kilohertz, but it can go up to 10 megahertz, but as the frequency increases, the signal just dies. When I change the waveform to a square wave, the frequency counter works even up till 10 megahertz. Unfortunately, the frequency counter module was only stable up to 100 kHz for all waveforms except square waves. Luckily, this isn't a problem for me because I intend to use this function generator only for audio frequencies and audio testing. For all other radio frequency testing, I have a proper signal generator that goes up to 100 megahertz. Okay, for example, it's now set to 100 kilohertz triangle wave. As soon as you go above 50, it starts just freaking out and not working anymore. Okay, so on the top again is the waveform going into the frequency counter, and as we increase the frequency to the point where it cuts off, and okay, this is the point where it cuts off, it probably starts seeing the small waveform as a separate wave as well, and then it can't count the frequency anymore. Okay, so just to recap, when I got this thing, it had no output, and the frequency counter module was displaying nothing. I was able to fix the output by just inserting this IC with a heatsink that fell out during shipping, and the frequency counter board I was able to fix by physically removing the pin of the IC from the socket and then connecting the output of the function generator chip to the pin on the socket for the sync. The sync pin was designed to synchronize with other chips in the system, but in this case it was used to connect to a inverter, which then sends a signal to a sync output and then to the frequency counter module. The Max 038 CPP chip is very similar to the XR2206 chip. They are very popular for use in DIY function generators. The only difference is that the Maxim chip can go up to 15 MHz, I believe, while the XR chip can only go up to 1 MHz. I believe both of these chips have been discontinued, but they can still be found on eBay, with the Maxim chip for about $10 and the XR chip for about $3. Click here to watch one of my other videos.